All right, so this is Trig section 2.8, choosing the best model. Yes, we are skipping section 2.7 for right now, but we'll catch that when we jump into chapter 3. The choosing the best model is not always the easiest, but we have a way of doing it, a couple different ways of doing it, but we can't use correlation coefficient. Correlation coefficient is only something that applies to the linear model. So we have to use something else. We have to use residuals. We've talked about how that's the same thing as deviations or errors. And we know that that is the observed y value minus the predicted y value. That's the formula for doing it, and we've done it with lists, and you should remember that. Now, we can plot those residuals. Whoops, sorry. And what is a residual plot? How do we plot those residuals? A residual plot is found by using those deviations. Here's what we do. We know that we have the observed x values in list 1. We put the observed y values in list 2. Then we calculate the predicted y values based on whichever model we're using. For instance, are we using the linear model, the quadratic model, the exponential model? And then, of course, we find the deviations, and we talked about how we do that. Observed minus predicted, in this case, list 2 minus list 3. But it's the observed y values minus the predicted y values. Well, what is a residual plot? A residual plot is nothing more than a scatter plot using list 1 for the x values and list 4 for the y values. And we'll set those up here in a minute. So let's grab the graphing calculator, which I don't know what I did with mine, so I'm going to have to pause the recording, or I'm just going to have to keep talking and hopefully you hear my voice and you're wondering where I'm at. And then I'll come back here and we've got to get some data entered in our calculator. So what kind of residual plots are good before we get to the example? Well, let's see. A residual plot could look like any of these. Here, I'll zoom in a little bit once I get this thing situated. All right, so here's the residual plot. This is actually a really good residual plot because what it shows me is that the data values fall along the model, whatever that model is. And as we do this, you'll understand more and more that a residual plot basically takes the curve and straightens it out. So imagine that that line that runs right through there is the actual model, whether it's the line or the quadratic or the exponential. We have, by doing the residual plot, we've actually straightened out the curve, and we're taking a look at how far the data points are away from that curve. And what I like about this one is you see a lot of points above, a lot of points below, no real pattern. It's kind of a horizontal band of values. Yes, you want to probably write that down. Horizontal band of values with no unique pattern, no recognizable patterns. This one is a bad one. All right, because it has a recognizable pattern. It really looks quadratic. So it does a bad job in the beginning, okay job there, bad job in the middle, okay job there, bad job at the end. So that's not a good model. So when you see a recognizable pattern, you know that that is not the correct model to choose. And this would also be a bad looking residual plot. It's not very accurate over here, but as we continue through the model, it starts getting more accurate, so that's not a very good one either. So let's take a look at an example. By the way, this is something you're going to do a lot of in your project. You're going to be finding residual plots. So this section, if you really pay attention to this section, which puts a lot of stuff from Chapter 2 together, this is what you're going to be doing a lot of in your project, to find out how the data correlates together and how it answers your question. Okay? So let's see here. We want to jump to the data on page 136. Let me back up here. You'll see that in the book. So for instance, here's the table if you want to enter that there's the information. Now I'm going to use, let's see here, what should we use? I'm probably going to use years after 1700. So when we get our values, and I get into my lists here, I'm going to use 90 for 1790, 100, and so forth. So 1810 would then be 110, 120, 130, 140, 150, 160, 170, 180, 190. And then we can continue with that pattern. 200, 210, 220, 230, 240, 250. Don't I wish I had this all entered in my calculator before I started the notes. 270, 280, but you're typing along the same time I am, so it doesn't really matter. And so then I can get my y values in there. 4, 5, 7, 10, 13, 17, 23, 31, 40. I know there's a few of you that are trying to race me to the end to see if you can beat me. And some of you are celebrating right now because you are faster at texting than I am. 1, 2, 3, 1, 3, 2, 1, 5, 1, 7, 9, 203, 227, 249. Okay, so we got all our data in the calculator. There it is. Let's find the linear model. Now we know how to find the linear model, right? Stat, calculate, linear regression, list 1, list 2. Okay? So here we go, we've got our model. Let me write that one down. Okay, then next we want to go through that whole idea and find the deviations. So we're going to go all the way through list 4 here. So back into my lists here. And in list 3, we're going to use that model, right? 1.215, list 1, minus 145.125. And we found our predicted y values. Okay. We move over to list 4, and we find the observed y values minus the predicted y values. And those are the deviations. Okay. So we'd like to find two things out of this. We'd like to find a residual plot, and just for fun, we're going to write down the sum of squared deviations. So let's set up our residual plot so we can take a look at that. Under scatter plot, remember that we want scatter plot, that's under the stat plot. But this time, remember, we want L1 and L4. That's what we were talking about when I drew that out. List 1 is your X's, list 4 is your Y's. Now, zoom 9 is what I need to do each time I want to do my new residual plot. If I don't go to zoom stat, I am not going to get the correct window. Alright, so there is my shape. That looks definitely recognizable. That is a bad looking residual plot right there. Okay, so here we have our linear residual plot, and it's doing something like this, and it's got a little hiccup there, but okay, it's doing so that one is definitely a bad residual plot. It's trying to tell me that this is not a linear model. And just for fun, we'll find the sum of the squared deviations, right? Sum of squared deviations. Because that's a numeric way of being able to tell what's going on. Whoa, lost my image. Where's my preview? Somewhere. Okay, there it is. Yeah, I really need to get on tune there. Hold on just a brief moment. Gosh darn it.